A very good day. I would like to speak to Dr. Aida binti Ali. So today, our group will be presenting our lab 5. And before we start our presentation, we would like to introduce ourselves first. My name is Muhammad Ziyaafser bin Muhammad Zina. I'm from Johor Bahru.
My name is Kagineswaran and I'm from Selangor.
My name is Hassan Sajid and I am from Johor Bahru.
My name is Vinodh and I'm from Selangor.
So first, we will start off with, we have 4 questions totally. So we will start off with question number 1.
All right, so for the first question, they asked to find the value of AL for each line of the code. So for the first row, first line of the code, we move 0110001 binary, which is 61 hexadecimal into AL. Then for the first row, second line of the code, we end 0001101 binary into the AL. So the value will be 1 hexadecimal. Then we move into the second row, first line, which is we move 12 hexadecimal into the AL. So then we move into the next line where we end 3b hexadecimal into AL. So the value will be 12 hexadecimal. Then for the third row, first line, we move 000111 binary, which is F hexadecimal into AL. Then third row, second line, we OR the 72 hexadecimal into AL. So the value will be 7F hexadecimal. Now moving on to the fourth row, first line, we move the 83 hexadecimal into AL. Then on the fourth row, second line, we move we XOR 26 hexadecimal into AL. So the value will be A5 hexadecimal.
All right, so for question 2, I'll be talking about the instructions that we have to do in assembly language code. All right, so for A, jumps to label L1 if either bit 4, 5, or 6 is set in the BL register. To do that, we first put test, and then the bit 6, 5, and 4 will be in 1, and then jump not equal to 0 to L1. Then for B, jumps to label L1 if bits 4, 5, and 6 are all set in BL register. We use the AND instruction to 0. This will be 6, 5, and 4 be setting to 1. And then you compare it with the same thing, and then jump if equal to L1. Okay, so for the C instruction, jumps to label L1 if AL has even parity. So you can either use OR or L. I use OR here to compare the AL. So if they have equal, even parity, jump parity is even, will be the conditional loop that we use, and then L2 will jump to L2. So for the instruction, jumps to label L3 if EAX is negative. So then you test EAX to EAX, so you're comparing these both, and then jump if it's a signed integer to L3. Okay, so for E, jumps to label as L4 is the expression EBX minus ECX is greater than 0. So you are subtracting ECX from EBX. And then after you subtract the EBX value from ECX, compare the EBX with 0. If it's less than that, then jump jump above, if I'm not mistaken, then I'll jump to L4. That's all for my part. Thank you.
So I will be now answering the question 3 of number 1. So in question A, in the code segment, here is given the value of EAX to 20. But if in the question, the question is, if EAX is 20, which condition jump is taken? Please explain your answer. Okay. So at first, for this, we have to differentiate the value of both EAX. So in the code segment, the value of EAX is 20, but in the question, the value of EAX 25. So if we differentiate the both of the values, we can find the value of EAX is greater. So based on the condition, of course, the value of EAX here will jump into L1, because this is a given condition that if the value is greater than the given value, then it will directly jump into L1. And the next question is, what is the final value of EVX? In here, the final value of EVX is 1, because in L1 we can see the final value of EVX, which is 1, directly moves into EVX. So the final value of EVX will be 1. And now let's move on to the question B, where the question is, why is the jump out instruction needed for the code segment? Please elaborate your answer. So in here, in the code segment, we can see there are two conditions actually, which is greater than and another one is less than. So if the value is greater, then it will directly jump into L1, and if the value is less, then it will directly jump into L2. But here we can see the value of EX is 25, which is greater than 20, so it will definitely jump into L1. So it doesn't make any sense whether the value of EAX will move into L2 as well. So to skip that portion of the code, we needed the jump out. We needed the jump out section, which directly skips the L2 part of our code segment. And we can see in the last line, we can find the out question is used to skip the L2 part. So yeah, this is the answer of my question B.
So moving on is the question 4. Basically, the question already gave us 80% of the code. I just have to copy and paste it on the compiler. So what the question wants us to do is that we need to find the sum of the integer the user puts. For example, if the user put 10, I have to get the final, I have to find as if like 1 plus 2 plus 3 plus 5 until 10. And I have to be using it in 3 different methods. So the first one is the simplest one, which is using loop. And here's the thing. All right. So we have to use loop. It's a direct way actually. So what I did is that I set the instruction or the flag first. In a simpler way, I made the registers to be 0. So I did this XOR EAX because this is the logical instruction. Because initially I did this code without this XOR, the calculation was wrong, even though the code runs. But after putting this method, I got this idea actually from YouTube, in which it's better to zero the register from start of each instruction. So now it can run well with the correct answer. So that's why I put it. And next I did the basic step for loop. I just add ECX into EAX, and then I loop it until 0. And in the end, I end it with RET, which is return, which means it returns to another new instruction. So that's for one Roman. Then moving on for the second question, I have second question was, yeah, this one. So second question, I have to use another alternative way, in which by using DEC and JNE, which means JNE means jump if not 0, and DEC is decrement. So what does JNE means is that it always jumps and stops at 0. This can be said as the manual way of what we did in the loop in the first question. So first I did the XOR thing for registers. I have to clear all the values in the register. Then I have to add ECX into EAX, and then the jump part will be executed. Then it will be like 10 plus 10 minus 1, which is 9, then plus with another decrement, which is 8 until 0. It's like the reverse order addition, kind of like that. So finally, I just return it with RET, and that's for question 2. And the third Roman, it's another method for calculating the same thing, but now I have to be using DEC, JECXZ, and jump. So JECXZ, it means it will jump when ECX is not 0. So first I clear the registers with XOR, then I add with ECX into EAX, decrement it, and then this JECXZ. Before it goes to L2, it has to jump first to L1 until it becomes 0. Then I just return it. So at the end, I will get the output as, let's try with any number. Wait, give me a moment. Okay, I have to share another screen. So this would be our output. It asks us to calculate this. So I enter a value. I just start with something simple. I just put 10. So this is the thing, using loop, using increment J and E, and the third question. So yeah, if we calculate it one by one, we will get 55. So that's why we're getting it for all the 3 questions. So that's it for question number 4. So moving on would be our reflection. So I did question 4 and I gained a lot, in which I was able to identify how to use loop and so many other methods that is similar to using loop. I use jump, I use increment and everything. So I really gained a lot from question 4. Yes, Kagineswaran, your
Alright.
reflection.
Yeah. So what I learned with doing question 2 is throughout lab 5, I have learned that the Boolean and comparison instructions can be implemented with conditional jumps as well to write specific program segments. And with this knowledge, I hope to make more practical codes in the future. That's all for me. Next, I'll be giving the stage to my friend Vinodh.
All right, as I do question 1, I think I have learned quite a lot, which is especially the logical instruction, which is the AND or XOR or NOT, because it shows me how it works in the assembly language. I think that's all for me. I think I'll give it to one of this one, Sajid.
Yes. So during my part was question 3. So during my lab, I think I have learned a lot about the jumping modules based on the greater than and some logical and illogical segments, which are based on some integer values, which can be greater and which can be less. And based on these assembly language coding segments, I think these things will help me in my future works and help me to outcome a lot of activities in future. That's all for me. Thank you.
All right, that's it from us. Thank you so much. Bye.